Good morning, students. We're going to discussing fourth problem in conceptual questions. If a comma b are two fixed points such that ab is equal to 3 and p is a point such that pa by pb is equal to 2, then maximum area of triangle pab is. So, whenever you observe this ratio pa by pb is equal to some 2 by 1, 2 means 2 by 1, then you just remember this diagram in coordinate system. Already I explained based on this diagram. So if you don't know, just you follow me. Whenever they given pa by pb is equal to some 2 by 1 and we need to find out the area of triangle pab, maximum area, then first you plot the triangle PAB. Here they given PA by PB they given. Okay. So take P as a vertex. Okay. You draw two internal and external angular bisectors. This is internal angular bisector. This is external angular bisector. Okay. So the angle between internal angular bisector and external angular bisector is nothing but 90 degrees. Already we know the angle between the angular bisectors is 90 degrees, or angular bisectors of any two lines are mutually perpendicular. Okay. So based on this one, this is 90 degrees. Okay. Whenever it is 90 degrees, we can draw a circle passing through pxy and xy as diameter. So here xy as diameter. So now whenever they given pa by pb is equal to 2 by 1, so it is the this px is internal angular bisector, so this is the x. So whenever internal angular bisector divides the base in the ratio of other two sides, because they given pa by pb is equal to 2 by 1, so px divides this ab base in the ratio of 2:1 internally. So this is in 10th class internal angular bisector. Actually this problem may they given in extra questions. Okay, in last page. So mostly who completed the theorem, they know very well. So px divides this AB in the ratio 2:1 internally. Same way, this is external divisor. So y divides same this AB in the ratio 2:1 externally. That means external formula for this one. For x you use internal formula, for y you use external formula. Okay. So to get the area of the triangle PAB, they given the length of AB, base length, they given AB is equal to 3. If you find the maximum height from P to this base, so that gives the maximum area. Formula of into base into height. So if height is more, that gives maximum area. If height is less, that gives minimum area. Okay. When it becomes to maximum, you will see here. Okay. So why you are drawing this one means, if you find out the x, okay, if you find out the here point x and y, okay, x and y, this xy gives diameter of the circle. Okay, then half of this diameter gives radius of the circle. Okay, so when this height is maximum means, okay, if this pb, okay, if this pb is radius, when it becomes to radius, if it is that means this height is coincident to, that means from p to if you drop a perpendicular that coincident to center of the circle, then we can say this is also maximum, this length also maximum. Otherwise, for suppose p here it is the center, if p is here, it is the maximum height. If p is moving like this or like this, p from p to this height, from p to this side, the height becomes to less. So when it is coincident to center, that gives maximum. That is only the radius of the circle. Radius only the from center to circle, that gives maximum length. Okay, remaining all lengths are less lengths. Okay, so that gives the maximum height. So using that height, you get the maximum area. Okay, so to find that one, x is equal to, so internal formula use, they given, let us consider, we don't know a and b points also, so but they given ab is equal to 3, assumption this is true for any different values of a comma b such that ab is equal to 3. Okay, so for our convenience just you go for take ab on x-axis and take a as origin, it is very obvious point, so that we that is reduce our work. Okay, and whenever a is on 0 comma 0 and ab is equal to 3, if you want to take b also on x-axis, b becomes to 3 comma 0. Okay, no problem, you get any 2 points such that ab is equal to 3. Okay, so these are the best points. So now x becomes to internal formula 2 into 3 plus 1 into 0 by 2 plus 1, next 2 into 0 plus 1 into 0 by 2 plus 1. So this gives 2 3s are 6, 6 by 3 that gives 2. So this is 0 by 3 that gives 0. So x is equal to 2 comma 0. So now for y, same formula apply, external formula. So in between you take a minus. So here, so 2 into 3, okay, minus here, minus 2 into 3 minus 1 into 0 by 2 minus 1. Next 2 into 0 minus 1 into 0 by 2 minus 1. So 6 by 1, that is 6 only, this is becomes to 0, 6 comma 0. Now we have xy is equal to, so x is equal to 2 comma 0, y is equal to 6 comma 0. So the distance between x and y is nothing but diameter. So xy diameter is equal to, it is 2 comma 0 6 comma 0 on x-axis only, so it is 2 comma 0, it is 6 comma 0, distance becomes to 4. So no need to apply distance formula also. So xy is equal to 4, that is diameter. So whenever xy is equal to diameter is equal to 4, then radius is equal to half of that 4, that is 2. So now that 2 gives, so this is whenever, if this height, whenever if you drop from p to this line, if you drop a perpendicular, if that coincident to center of the circle, that gives the maximum height. So whenever that gives the maximum height, that is also radius. Okay, so radius here you got 2 only, so that is only the height of the triangle PAB. So PAB length they give, AB length they given, so half into base is equal to 3 and height is equal to 2, half into base into height, so 2 get cancelled, that is equal to 3 square units. So this is the answer for this question. So very conceptual question. Next question, the area of the triangle whose vertices are b comma c, c comma a comma b is delta, and area of the triangle whose vertices ac minus b square, ab minus c square, ab minus c square, bc minus a square, bc minus a square, ac minus b square is delta dash, and if a comma b comma c are sides of the another triangle whose perimeter is 16, then delta dash by delta power 1 by 8 is dash. Actually this problem based on determinants, so who completed already, most of you listened determinants. Okay, some few students may join newly, so if you don't know, so don't bother, I will explain later determinants. Okay, until you just read this, just follow me when if you understand. Okay, otherwise you ask in some other time. Okay, after completion of determinants. Now, so area of the triangle whose vertices are BC, CA, AB is delta they given, and the area of the triangle whose vertices and they given this the one triangle for area delta, another triangle for area delta dash. If ABC are the sides of another triangle, this is also for another triangle they given whose perimeter is 16. Okay, whose perimeter is 16. So they given 3 different triangles. So for one triangle perimeter is whose sides are ABC is 16 they given. So use that one. First condition, a plus b plus c is equal to 16. Next one. So area of the triangle formed by these 3 vertices is delta they given. That is BC, CA, AB. So area of the triangle delta is equal to half into modulus of determinant of. Actually we can use this formula whenever you have x1, y1, x2, y2, x3, y3 are 3 vertices of a triangle, then area is equal to half into x1, y1, x2, y2, x3, y3 and x1, y1 modulus of determinant half into x1. Otherwise you can use this formula also here. x1, x2, x3, y1, y2, y3, and 1, 1, 1 also we can use same formula of into. Okay, so you can use this formula. This one is actually to find the area of the triangle we have different formulas, many formulas. All those formulas are formed by this one only. So for our convenient, which one you want you can take. So whenever they given single digits, some b, c, c, a, b, use this formula. Whenever they given some clumsy coordinates a, c minus b square, you use this one. So here it is in determinant only maximum. So whenever this is clumsy, they give it is by determinant 3 by the determinant. It is a cross multiplication method. It is determinant method. Okay, by using 3 vertices. So here a plus b plus c is equal to 16 they given, and for triangle whose vertices are bc, ca, ab, I am using this formula, that is bc. I am using this formula bc, ca, ab, and ending with bc only. So expand this one, cross multiplications only. So determinant will be eliminated. Just use modulus form. So b ab minus c square plus, in between you should write plus cb, that means bc also you can write cb minus a square. Next cross multiplication ac minus b square. So the write comfortably off into ab plus bc plus ca minus a square minus b square minus c square. So next one, so delta dash they given. So that is the triangle, another triangle area whose vertices are these given. So I am using this formula for this one 1 1 1. Whenever you take like this 1 1 1, so expansion of determinant is very easy. So we know how to expand whenever you have the any one row or one column has all or ones. Okay, so for that convenient, you just I am writing AC minus, this is x1, x2, x3, y1, y2, y3. These are the 1 1 1. Always we have to write fixed. Okay, so this to actually whenever you have ones in any one row or column, just if those are in columns, use row operation. Those are in columns, use row operation. If those are in rows, you should use column operation. So here ones are in columns. So for third column, so apply row operation to make two elements are zeros. If you make two elements are zeros, so you can expand easily. Okay, r1 implies r1 minus r2. Whenever, if you don't know, who don't know determinant, just follow me. What is r1 minus r2 means? So this is the first row, this is second row, this is third row. Okay, r1 minus r2 means so from r1, this is r1 element, this is r2 element, corresponding elements. These two are corresponding elements, these two are corresponding elements. Subtract from this one to this one, this one to this one, this one to this one. So then the new determinant becomes unaltered. That means what it gives same answer for after applying this row operation also. Okay, so that means, so then you get this becomes to 0 because 1 minus 1 0. Okay, next one, if you use r2 minus r3 also, this becomes to 0. If any two elements are 0, so expand through that column easily. Okay, so for that one, so use r1 minus r2, that means ac minus b square minus of ab minus c square. Actually I didn't write here, so that expansion what you get I have written here. See here, so whenever ac minus b square minus of ab minus c square, ac minus b square minus of ab minus c square means minus ab plus c square. Okay, so this gives, if you use these two terms, take a common, c minus b. If you use these two terms, c square minus b square, that means c plus b into c minus b. So from these two terms now we have c minus b is common. If you take c minus b common, you have a plus b plus c. Okay, that means ac minus b square minus of ab minus c square gives c minus b into a plus b plus c. Similarly, ab minus c square minus bc plus a square, which because r1 minus r2, from this one you have to subtract this one. Okay, so that gives, if you apply same procedure, a plus b plus c into a minus c. Okay, here what you get, c minus b. So remaining all of them are a plus b plus c only. So c minus b means this to this one. So here a plus b plus c into you get a minus c. So this is only, so 1 minus 1 0. Next r2 minus r3, so subtract this one from this one, ab minus c square minus of bc minus a square, that gives same answer, a plus b plus c into a minus c. This procedure if you apply. Next one, bc minus a square minus of ac minus b square means a plus b plus c into b minus a. So this one. Next 1 minus 1 becomes to 0. So write the third row as it is, because I didn't use the third row. Okay, didn't use means I am not changing third row. So R1 implies means R1 is going to change, R2 implies means R2 is going to change. Here R3 I didn't operate. Okay, so that's why. So this is the determinant expansion. So now from this row we have a plus b plus c is common. You can take one a plus b plus c, and from second row also we have a plus b plus c common. 0 for 0 no meaning, so no problem. So that's why a plus b plus c you can take from second row, and a plus b plus c you can take from first row. So 2 a plus b plus c into a plus b plus c, that gives a plus b plus c whole square. Remaining c minus b, a minus c 0, a minus c, b minus a 0, bc minus a square, ac minus b square 1. Okay, so this is equal to half of a plus b plus c whole square into, so expand through last column. Actually here plus minus plus minus plus, expand it. Okay, so for this 0 plus, for this 0 minus, so 0 into anything is 0, so don't operate for this 0. 0 into anything is 0, don't operate, so directly go for 1. So leave the round column. What you have, c minus b into b minus a, minus of a minus c into a minus c. So expand this one, cb minus ca minus b square plus ab minus of a square, that means a minus c whole square only, a square plus c square minus 2ac. If you apply minus inside, so cb minus ca minus b square plus ab minus a square minus c square plus 2ac. So simplify, ab plus bc plus ca minus a square minus b square minus c square. Actually here minus cm plus 2ac, that gives plus ac. So remaining are ab, bc is there, and one more ca, this one. So actually this is nothing but, half of this is nothing but delta, according to first one. Half of this one is nothing but delta, so that means this one is equal to 2 delta. So just you write 2 delta, and a plus b plus c they given perimeter 16, so apply 16 also here. So this is equal to 2 get cancelled, this is 16 square into delta. So this is totally 16 square, you can write as 2 power 8 into delta. He is asking to find the value of delta dash by delta. So this delta transpose this side, so then you get delta dash by delta is equal to 2 power 8. So he is asking to find out, so delta dash by delta whole power 1 by 8. So 8 transpose this side, 1 by 8 becomes 2. So this is equal to 2. 2 is the answer for this question.